So today we are going to start an important chapter, and that is chemical energetics. Basically, in this chapter, we will learn about the exothermic reactions and endothermic reactions and their energy profile diagrams. Okay, first of all, what is meant by exothermic? Now, exo means out, and therm mean heat. Okay, means heat is coming out. Those reactions from which heat comes out, those are known as exothermic reactions. Okay, now what's the definition is chemical reaction in which heat is released are known as exothermic reactions. Okay, features. What are the features of exothermic reactions? Heat transfers from system to surrounding. What does it mean? Suppose this is a system, this is the system. Okay, sorry, so this is the system, whatever it is, this is system, and heat will comes out from this system to the surroundings, because reaction is takes place over here, and the heat will comes out, so heat will comes out to the surroundings. So this is what, this is exothermic reaction. Okay, and at the start of the reaction, there is an increase of temperature in the system measured with the help of thermometer. This is thermometer. Okay, then the temperature of the system decreases and the temperature of the surrounding increases. Obviously, first of all, when the heat will comes out from this, so firstly in the at initial stage, its temperature will increase, but after some time heat will comes out, so the temperature of the surrounding will increase, and the surrounding and the temperature of this system will decrease after some time. Okay, as you know very well that when the heat comes out from here, these walls becomes hot. Okay, okay, low activation energy is required to initiate or to start these chemical reactions, exothermic reactions. We are talking about exothermic reactions. Okay, and delta H is always negative. Okay, it's the basically recognition of exothermic reaction that they have negative delta H, negative enthalpy change. Now looking forward towards the energy profile diagram of exothermic reactions. Now here we will have our products, here we will have our here we will have reactants, and here we will have products. So to start this reaction, we need some energy to start this, and like this. Okay, this is the activation energy, which will be represented by EA. This is activation energy. Okay, and this is from here to here. This one is what, that sorry, this is delta H, means enthalpy change. That is always negative for, that is always for negative for exothermic reactions. Okay, now moving for, and here these axes are very important because the examiner asks you to label these axes. So this is reaction pathway, or you can say reaction progress, and here we have energy or potential energy, you can say. Okay, now the graphical representation of exothermic reactions is like this. Okay, it's basically a question or MCQ question that the examiner asks you what is the graphical representation of exothermic reaction, and he will provide you some graphs, some maybe like this, like this, like this, and one will be like this, or one will be like this. So you have to opt this one for exothermic reactions. Okay, now we're going to talk about endothermic reactions. Chemical reactions, one most important thing, endothermic is opposite to the and exothermic. Okay, now endo means in and therm in heat. So what does the endothermic mean? Heat comes in. Okay, now chemical reaction in which heat is absorbed are known as endothermic reactions. Okay, what are the features? What are the features of endothermic reactions? Now, heat transfers from surrounding. They will, as you know, that they absorb heat. So this is the system, and these are our surroundings. So they will absorb heat from here to here. Heat will comes in from the surroundings to the system. Okay. Now, at the start, the temperature of the system, there is a decrease in the system. Okay, it means initially the temperature of this system will be lower and the temperature of the surrounding will be higher. Okay, but after some time, when the system will absorb energy, the temperature of this system will increase and the temperature of the surrounding will decrease. Okay, and when the heat comes in from this, so these walls transfer heat from here to onward here, and then the walls of this system, or you can say beaker, will becomes cold because the heat will transfer from here to here in the system. Okay, now, and the delta H is always positive for what? For endothermic reactions. Now, looking forward towards the energy profile diagram. Reaction progress. Here we have potential energy. Now, in endothermic, we have reactants at lower energy. While products are at higher energy. If you notice that in exothermic reactions we have opposite, because the reactants were on high energy and products were at low energy. Now, delta H is very high. Activation energy is very high in endothermic reactions. So we need to provide a huge energy to start this reaction. So if you notice that this is activation energy. If you can see, just notice that in exothermic reaction we have just a little amount of activation energy, but in endothermic reaction we have a huge amount of activation energy. Okay, so high energy is required to start these reactions, and this one is delta H, that is always positive for endothermic reactions. Okay, so I hope it's clear to you. And the graphical representation is also the opposite to the exothermic. In exothermic it was like this, but in endo it is like this. Okay, so these are opposite. Okay, Now, this is the basically the past paper question which the examiner asked to the students. Explanation of exothermic reaction in terms of bond breaking and bond making. This is uh, most probably for 3 to 2 marks. Okay, you have to copy which I have written over here, because this thing will gives you 2 marks or 3 marks full. Bond breaking is an endothermic reaction, and bond making is an exothermic process. In an exothermic reaction, less energy is absorbed in bond making and more energy is released in bond making. So this is for endothermic, this is for exothermic, but just the words are going to be changed, otherwise the statement is same. So I hope it's clear to you. If you have any queries, you can ask me and I'll ask you reply you as soon as possible. So thanks.